Hi guys. We're going to continue with solving polynomial equations. This will be similar to our first video from yesterday. However, in yesterday's first video, everything was factorable. In today, we're going to factor, but we're going to get to a point where we can't factor anymore. So we're going to get some other weird answers, not the nice answers we always get from factoring. We'll do 2 examples in each video. Here is our first example. Before starting this problem, let's figure out how many answers it's going to have so that we will know if we've solved it completely. In this problem, I should have 3 answers because my biggest exponent is the number 3. This is x to the third right here. All right, now that I know how many answers to expect, let's go ahead and start solving this. To begin solving this, I need it to be in standard form. Standard form should have everything on one side of the equal sign, and it should be equal to 0. We also want to make sure that our exponents are in descending order. So I'm going to minus the 3x to the other side, and I'm going to stick it at the end of the problem, so it goes x to the third, x squared, x. Now I can start factoring. I'm going to start by taking out a GCF, similar to what we did yesterday. Now this is a trinomial. It's a little bit more difficult than yesterday's trinomials. For this trinomial, you'll have to do the x and the box, because there's a 2 in front of the x squared. For the x, I'm going to multiply the 2 times the negative 3, which gives me a negative 6 on the top. And then I have the negative 5 on the bottom. Now don't be fooled. The sides are not 2 and 3. 2 times 3 is 6, but one of them will need to be negative, which means we'll be subtracting, and 2 minus 3 is not negative 5. So instead, for the sides of the x, we'll be using negative 6 and 1. Negative 6 times 1 is negative 6. Negative 6 plus 1 is negative 5. Now again, because there was a 2 in front of my x squared, I will need to use the box for this problem. To use the box, we're going to put the 2x squared in the first box, the negative 3 in the last box, and we'll take the negative 6 and the 1 from the sides of the x and put them on the diagonal. Then we factor out a GCF of 2x, x, negative 3, and positive 1. And so now I have my fully factored form of this polynomial. From here, I can now get my 3 answers from my 3 separate parts, right? So I have 2 parentheses, and then I have that GCF of x in the front. So my GCF gives me an answer of 0. The parentheses that had a 2x, it's going to get a fractional answer. So I'm going to minus the 1, and then I'll divide by 2. So it's going to be a fraction. That's okay. And then for the last parentheses, we'll add the 3 over, and we'll get positive 3. So here are the 3 answers to this problem. We did expect to get 3 answers, and we got 3 answers, so that's good. Really quickly, I wanted to show you what those answers mean and what the graph looks like. So this was a cubic, which means that it's going to start low and it's going to rise up. So if we look at the graph and we can look at it a little bit bigger, it starts down here at the bottom and then it goes up and then it goes up like this. So this is a cubic, starts low and rises up. And then the 3 answers that we got, those are telling me my x-intercepts. So if we look, it's crossing at negative 1/2 right here, 0 right here, and 3 over here. So remember that the answers, the solutions, are your x-intercepts. Here's our second example. Again, I like to predict how many answers there are going to be before starting the problem so that I make sure when I'm done with the problem that I did find all of my answers. In this problem, I will expect 4 answers since my highest exponent is x to the 4th. Similar to our previous problem, I will be moving the 6x to the 3rd to the other side so that it's equal to 0. Now I put it in the middle of the problem so that it's in standard form, descending order, x to the 4th, x to the 3rd, x squared. That's important for factoring. Also, similar to our previous problem, I will be factoring out a GCF. In this problem, I can factor out more than just a variable. So I can factor out a letter x. In fact, I can factor out an x squared since x squared is the smallest exponent. But I can also factor out a 3 since all of these numbers are divisible by 3. So 3x squared outside. Next, I'm going to factor the inside. The inside is a trinomial, so I can try xbox. Sometimes xbox doesn't work. If xbox doesn't work, we'll talk about other ways that you can solve a trinomial. Xbox doesn't work for this one. That's okay. We have other methods. So this is as factored as I can get it. And that's fine. It is what it is. Since each of these pieces has an x squared in it, each of the parts will give me 2 answers. So the 3x squared will give me 2 answers, and then the x squared minus 2x plus 4 will also give me 2 answers. For the 3x squared, the answers are very, very simple. It's still that number 0. So anytime you have a GCF of x, you're always going to get an answer of 0. Since it's an x squared, that means that it will have a multiplicity of 2. We get the answer of 0 twice. So 2 of the answers are the number 0. We're only going to write it once, and we'll say it has a multiplicity of 2. Now, when a trinomial is not factorable, that doesn't mean it doesn't have an answer. That just means that we have to find a different method. And that method is quadratic formula. So we're going to use quadratic formula for this problem. Here's the quadratic formula if you don't remember. We did learn this before winter break. I'm going to go quickly through the quadratic formula. You should already know how to do this. Notice that underneath my radical is a negative sign. That means that I'm going to get some imaginary answers. Remember that if an answer is an imaginary, that means that it is not going to cross the x-axis there because it doesn't exist. It's not real. So here are my 4 answers. 4 answers. 2 answers are 0, and then 1 plus IRAD 3 and 1 minus IRAD 3 are my other 2 answers. Okay, so 4 answers total. Let's take a look at the graph for this. Now this kind of looks like a parabola. It was an x to the 4th, so it's going to have the same attributes as a parabola does, where it starts high and it ends high. So that is important. That's what we were expecting. This only has one real root, just the number 0. So remember, it had 2 imaginary roots. Those are not going to show up on the graph. And then the number 0, it had a multiplicity of 2. And so when it has a multiplicity that's an even number, that means that it's going to brush against the x-axis, but it's not going to like travel through the x-axis. So remember on the other ones, it like started low and then it crossed it and it crossed it and it crossed it. If the multiplicity is an even number, like the number 2, it's not going to cross through. It's just going to barely skim over the surface of the x-axis. This concludes our first video for today.